Thank you for clicking on that thumbnail. This is the solution video of Summer 2022 A and AS level math of Cambridge International, paper 31, pure math 3. Question number 1 says, solve this exponential equation. Here we see that x's are the exponents. To bring down the exponents, we apply log to both sides. So it will become log 2 3 to the power 2x minus 1 and put a bracket here, because this log is being applied to whole of the left side and whole of the right side, but right side has only one term. Okay, left side has two of them, so that's why we have to put a bigger bracket there. So now there are two terms which are multiplying, 2 and this. Whenever two terms multiply inside log, we separate them by adding and putting a log in front of both of them. That's the logarithmic rule. So 2 is separated from this bracket and we put a plus here and both have logs now. Similarly here, log, it will be 4x plus 1 exponent. Okay, purpose was that this exponent can become a coefficient. So log 2, nothing happens to this one. Now we can write without bracket 2x minus 1, the whole of it will multiply with log and whatever was the base was 3, right, equal to, similarly here, x plus 1, whole of it multiplying with log 4, not base 4. Okay, now our purpose is to focus on x's. There are two x's, we have to combine them. For combining, first this minus 1 and this plus 1 must go away. So let's open the brackets here. So log 2 plus 2x log 3, 2x multiplied with log 3, they are multiplying, right, minus log 3 equal to x log 4 plus log 4. So whatever was inside the bracket multiplied with the log. Now this has x, this has x, let's keep them together. So 2x log 3 stays where it is. This x log 4 will come to the left side. We'll change its sign. Now log 2 is positive here, this is negative here. So both of them will change their signs. So log 4 is already on the right side. Log 3 becomes positive and log 2 becomes negative. Now both have x's, take that x common. We are left with log 2, 3, minus log 4, no, I have to write more, minus log 4 equal to, and there are 3 logs, let's combine them. These two are multiplying, so these are adding. Log 4 and log 3 are adding, so we'll do the reverse of what we did here. If two logs are adding, we can write them as the multiplication. So 4 multiplies with 3. But 2 is subtracting, so we will divide it by 2. Anything that subtracts, divides, they must have log in front of them, and they have. Similarly here, x, this 2 coefficient becomes the exponent, which we did here, the opposite of that. We bring 2x minus 1 in front. Here we will make it a exponent. Okay, it's subtracting, so let's write that one here. Equal to log, how much? 4 times 3 is 12, divided by 2, 6. Now x, this becomes log 9 minus log 4, right, equal to log 6. And we will complete it here. Log 9 and log 4 are subtracting, so it will become what? X log 9 over 4 equal to log 6. And x becomes log 6 divided by log 9 over 4. If you want to write that in decimal, you can write 2.25. 9 divided by 4 will be 2.25. And finally, we'll get our value. Just use your calculator and it'll give you the value. What we get here is 2.2095. Rounded off to 3 significant figures, 2.21. That is the value of x. Expand this binomial by in ascending or powers of x up to and including the term x to the power 4, simplifying the coefficients. Okay, first of all, the formula you have in your exams has a 1 in place of this 2. So let me change it. 2 minus x squared to the power minus. This is the question. We have to expand it. Divide here by 2. Divide here by 2. That means you have divided whole of it by 2. So you have to multiply also by 2. Multiply outside. But since the ones inside have an exponent of minus 2, the outside one should also have an exponent of minus 2. Right? So 1 over 2 square. And now 2 divided by 2 is 1 minus x square over 2 to the power minus 2. Now we have a 1 and we can use the formula which is given in your formula sheet, which is 1 plus, when we expand a binomial, 1 plus nx plus n minus 1, 2 factorial x square and so on. Now this is 1 over 4, keep it out, start a big bracket. First thing will be 1, then plus nx. N is the exponent, so exponent is minus 2. And x is, if you look at the left side of that one, it is 1 plus x to the power n, right? Here it is x, that's why it is x. But in our question, it is x, negative x square over 2. And that's what we will write here. X square over 2, negative, right? Next, plus n, which is minus 2, and minus 1. Minus 2 minus 1 divided by 2 factorial is just 2. 2 times 1 is 2. And in place of x again, we will write negative x square over 2. And because there is a square here, we'll put it. They're saying up to, including the term x to the power 4, and this is x square square. This is x to the power 4. That means we do not need to go further because it is up to x to the power 4 we need. So our expansion stops here. So 1 over 4, 1. This 2 and this 2 can cancel. This negative x, yeah, and this negative x, they become positive x. Okay, next this 2 and this 2 again cancels, and this negative become positive, and we are left with just 3. And what is left here? This negative will be positive because of the square. Square of a negative number is positive, and we'll get here x to the power 4 over 2 square is 4. Okay, so do we simplify? Yes, we simplify this. 1 over 4, 1 plus x plus 3/4 of x to the power 4. This is the expansion of this question. Do we have a part? Because A is written here, so we'll have a B part also. Okay, here it is. State the set of values of x for which the expansion is valid. Okay, let's go back to our question. Let me write what we got here. Let me copy this one. Okay, 1 over 4, 1 minus x square minus square. Okay, 1 over 4, 1 minus x square over 2 square. This is what we expanded, right? Now they're saying state the set values of x for which expansion is valid. The expansion is valid when your bracket, the contents of this bracket are positive, and it will be positive only if this 1 is greater than x square over 2, isn't it? 1 minus something will give you a positive number, and then positive will be, oh sorry, it was minus 2 here. So that is the rule, that we should have a positive inside. And if I do it here, cross multiply, 2 is greater than x square, isn't it? We can rewrite here x square is less than 2, square root both sides. So x will be less than square root 2 only, not plus minus. I'm not writing plus or minus here. Usually when we square root we do this, but this is an inequality. So what can we do? We can write an absolute sign here. It means that for both plus and minus, this is the solution. So this is your final answer. All right. What about question number 3? Question number 3 says solve this trigonometric equation. The challenge here is that both terms on the left side have cot, right? And we don't have any button on our calculator which has cot. So what should we do? We should change them to tan, because we know that cot A equal to 1 over tan A. Yeah, and that's what we will do here. Mind it, cot will become tan, not this 2. That means 2 will remain the numerator over tan 2x, right? Similarly, 3 will remain 3, so plus 3 over tan x and equal to 5. This is our equation, and somehow these two tans must be on numerator. So let's try to expand this. So we have another identity which is tan 2a equal to 2 tan a over 1 minus tan square a, right? And that's what we're going to use in place of this. Since it's a denominator, we will write the reciprocal of this, not exactly this, but reciprocal. So 2 is already here. This 1 minus tan square will be on numerator, tan square x divided by 2 tan x. Okay, 2 and 2 cancel here. What about here? 3 over tan. It is simple tan, so we'll keep it tan. And good thing we can see here that both of them have same denominator. That means we can combine the two. 1 minus tan square x plus 3 over tan x equal to 5, and we can cross multiply this tan x here. What do we get? 1 minus, or rather we can solve 1 and 3, 4, right? 4 minus tan square x equal to 5 tan x. 3 plus 1 is 4. Okay, let's keep left side blank and bring this 4 minus tan square to the other side. It becomes a quadratic equation now. That's what we wanted. Plus 5 tan x minus 4. Okay, so we cannot make factors out of it. So that means we'll have to use a quadratic formula. So what is quadratic formula? Minus b plus that is x equal to, okay, rather in this case tan x. This tan x is our variable. Okay, minus b plus minus square root b square minus 4ac over 2a. This is the quadratic formula, and this is what we're going to use here. Let's use it. Let's identify AB first. So there is 1 in front of this, which becomes A, plus 5 becomes B, and minus 4 becomes C. So minus B plus minus B square minus 4 times A C over 2 times 1. So what do we get? Minus 5 plus minus 25 plus 16 over 2. Yeah, so let's complete it here now. What do we get here? Minus 5 plus minus square root 41 over 2. So we got two answers for tan x. X is not our variable, x is our variable, but we are considering tan x as the variable for the quadratic. So tan x equal to, so we get two answers here, minus 5 plus square root 41 over 2, and minus the one which has plus will give us, if I use my calculator, I get 0.701562, and if I choose the minus 5 minus square root 41 over 2, I get negative 0.5, not 0.5, it is 5 point, sorry, negative 5.70156 and more digits, but we'll use this one. So let's focus on this. Let's see what domain they had given, 0 to 180, correct? That was the domain. So we'll use the domain here. So this is positive, correct? Positive means tan is positive here. Whatever angle we will get by tan inverse x equal to tan inverse 0.701562 will be this angle. And what angle I'm getting here is 35.05. So we can round it off to 3 significant figures. It becomes 35.1 and 1 decimal place of degrees. This is the first answer. Because tan is positive here also, but our domain is not in this region. That's why we will not look for that one. Now here tan is negative and we will use this here. So for this, x equal to tan inverse negative, not negative this time, positive 5.70156. Once we have decided our quadrant, there is no need to enter negative. If you put negative, you may not get answer here. You may get also, but try not to put, because we know the this quadrant now. I got this as about 80.06. So we know this is not our answer, 80.06. It is, we always calculate from 0. That's why it was 35.05, because it was from 0. So second answer will be from here till here. So 180 is this line, 80.06 less than 180 will be our answer. So x equal to 180 minus 80.06, which is a 99.94 degrees. Round it off to 99.91 decimal place. This is the second answer. These are the two answers for this question. Okay. See, the variables x and y satisfy the differential equation this, okay, and y equal to 2 when x is 0. This is secondary information they have given besides the differential equation. This will help us to find the constants we'll get during integration. Okay, solve the differential equation, obtaining a simplified expression for y in terms of x. So whenever we want to solve differential equation, separate dy and dx. And while separating them, both of them must be numerators. So dy was a numerator already. We made dx also a numerator. Second step should be that y should be with dy and x should be with dx. The combination, right? If you can separate. And yes, it can become 1 over y dy equal to x over 1 plus x squared dx. So y is with dy as combination of x's is dx. And to solve, next step should be integrate both sides. Integration of 1 over y is simple, ln y. Okay, this one will need some legwork. Let's do that. We want to integrate x 1 plus x squared dx, correct? So let assume, look, x square is degree 2 and we have only one term here which is degree 1. So that means this can be converted to the differentiation of this. So let 1 plus x square be equal to say u. So du over dx, differentiating it with respect to x will be 2x. We have just x here. So do what? Write 2 in front of this and multiply by half. So half times 2 is 1 again. So we have just changed the look. We have not changed the integration, the whole of integration. Okay. So now we can write here du is equal to 2x dx, right? Dx goes and multiplies here. So now what our question becomes? It becomes half du over 1 plus x square is u. So we can write something like this, half 1 over u du, and that gives us the integration equal to half ln u. And what was u? X square, because u was our creation. We should, whenever we write here, we should come back to what was originally there in the question. Okay, plus c. Okay, before I evaluate c, let's combine these two. So ln y minus half natural log 1 plus x square is equal to c. All right. So we can't combine these two unless this half goes away. This half will go and become the exponent here. So ln y minus ln 1 plus x square to the power half is equal to c. So now we can combine these two. Because two logs are subtracting, we can divide them inside. Y over square root means, sorry, power half means 1 over 1 plus x square root. That's what I'll do, equal to c. So let's remove log. Y over square root 1 plus x square equal to e to power c. E is a constant, c is a constant, so we can write this as also a constant. So y over, rather let's multiply these two. Y, because they want y in terms of x, right? So we can write k, e to power c, let's write it a constant, 1 plus x square. Now we have to evaluate this k. What is the value of k? And for this k, we need the information they are given. Y is equal to 2 when x is 0. So let's do it here. When x is 0, y is 2. So 2 equal to k 1 plus 0 square. So 1 plus 0 square is square root 1. So k comes out to be 2. So our equation becomes y equal to finally 2 square root 1 plus x square. We evaluated k as well. Okay, let's go to the next one, which is this one. The polynomial, this one where a and b are constants, is denoted by px. It is given that this is a factor of both px and p prime x. Okay, so let's do what? Px we already know. Let me rewrite it. Px is ax cube minus 10x square plus bx plus 8. Right, and what will be the p prime x? That means differentiation of this will be 3 comes in front, 3ax square minus 20x plus b. X minus 2 is a factor of both. That means by remainder theorem, if I substitute x equal to 2, how to convert it to root? X minus 2 is equal to 0. Yeah, we make the root 0. That means whole polynomial will become 0 because it's a factor of that polynomial. X equal to 2. That's how we convert a factor to a root by equating it equal to 0. All right. So P0, not P0, P2 is equal to a 2 cube minus 10 2 square plus b 2 plus 8. should be equal to 0 because root is 0. The 0 multiplied by anything will make this whole polynomial 0, and that's why I'm writing whole polynomial 0. This is called remainder theorem or factor theorem, sometimes people also call it. So what do we call it? What do we get here? 8a minus 40 plus 2b plus 8 equal to 0. So let's bring numbers to the right side. So 8a plus 2b equal to minus 40 plus 8 is minus 32. Make it positive 32 here. All are even, so let's divide all of them by 2 so that it becomes simpler. 4a plus b equal to 16. This becomes equation number 1. Now x minus 2 a factor of this also. P prime 2 is equal to 3a2 square minus 20 times 2 plus b. It should also be equal to 0. 4 times 3, 12a minus 40 plus b equal to 0. Keep a and b on one side and bring 40 to the other side. This is equation number 2. So we have b here, we have b here. Let's subtract 4a plus b equal to 16. Subtract this equation from equation number 2. So 12 minus 4, 8a, b minus b gone, 24. So divide by 8, divide by a is 24 divided by 8, 3. We got a. So can we get b here? Let's substitute here. 4 times 3 plus b equal to 16, 12. So b equal to 16 minus 12, b is 4. So we got a and b, both of them. So what was the equation? It was ax cube minus 10x square. Let me write here. A is 3 now. 3x cube minus 10x square plus b x plus 8. That was the polynomial, right? And we have to factor this polynomial. Okay. If I divide this whole polynomial by x minus 2, I should get a remainder of 0, and I will get the second factor here, which will be a quadratic, because this is degree 3, this is degree 1, so we'll get a quadratic, and we'll again get we can factor that quadratic easily. So x, what should I multiply with x to get a 3x cube? 3x square. So 3x cube minus 2 times this minus 6x square. Then we subtract. This cancels. Minus 10 plus 6 is minus 4x square. Then we have 4x plus 8. Now x should be multiplied by minus 4x to get minus 4x square. So minus 4x times minus 2 will be positive 8x. So minus, cancel. 4 minus 8x will be minus 4x plus 8. And now we'll multiply minus 4 here, minus 4x plus 8. Yes, we got 0 remainder, and that certifies that our values of a and b were perfect. But we have not factorize it completely. So one factor is x minus 2 rather, and the other one is 3x square minus 4x minus 4. We have to factor this also to get the other two, and I can use factoring method in this. 4 times 3 is 12, so 6 and 4. Let me focus on this one. Okay, so 3x square minus 6x plus 2x minus 4. So 3x on x minus 2 plus 2x minus 2. Taken common, x minus 2. Another factor x minus 2. Wow. So we have 2x minus 2. It's a square. So we got this one, and we already had x minus 2. So there are double roots of 2. So what will be, this is the complete factor. we can write it now x minus 2 square 3x plus 2. That's the complete factorization of this. All right, question number 6. Let I be this definite integral. Using substitution x equal to 3 tan theta, show that it can be converted to this one. Okay, so let's do the additional work here. So they said x equal to tan theta. That's what we have to substitute. So let's first differentiate it with respect to theta. So we'll get 3 secant square theta. That means dx can be replaced by 3 secant square theta d theta. Now we have to change the limits. So let's talk about this 0 first. So when x is 0, this x is 0, what will be theta? So 0 equal to 3 tan theta, and if we divide both sides by 3, 0 equal to tan theta, and theta will be tan inverse 0. So it is tan inverse 0 is 0 because it is starting from 0, so we get angle also equal to 0. Second limit is 3. When x is 3, 3 equal to 3 tan theta, cancel, 1 equal to tan theta, so tan theta equal to tan inverse 1, which is pi by 4 in first quadrant immediately after 0. So we got our limits 0 and 1/4 of pi. Now we have to get the main part, cos square theta. Let's do it here. Let's substitute everything. So it becomes 0, it becomes 1 over 4 pi, 27 is, let's write 27 outside. So 1 over 9 plus cos x square. If this is 3 tan theta, what will be x square? So because of this, we'll know that x square is square both sides. So 3 square is 9 tan square theta. So we'll write 9 tan square theta, as it is also squared. And then we have dx, we just got it 3 secant square theta d theta. So 3 secant square theta d theta. Okay, 27 is out. Okay, 3, we can multiply this 3 also outside, right? So it becomes 27 times 3, 81. 81. 0 to 1 over 4 pi, 3 is out, secant square theta d theta. Now just like the one in binomial expansion in previous questions, we'll take this 9 out. We'll divide both by 9. That means we have to multiply by 9 outside with this exponent. Yeah. So 9 square is 81. We can write 81 as denominator because 9 square is denominator here in this case. And what is left inside? 1 plus tan square theta square. Right? Now 81 and 81 cancelled out. So we are left with 1 over 4 pi secant square theta d theta over 1 plus tan square theta is secant square theta. That is an identity. So secant square theta square becomes secant 4 theta. Yeah. And now we can cancel 2 of them with 2 of them. So what are we left with? We are left with here, let me write 1 over secant square theta d theta. And 1 over secant theta is cos theta. So 1 over 4 pi cos square theta d theta. This is what they wanted us to show. This is the step. Okay. What next? B part. Hence, find the exact value of I. That means evaluate that definite integral 0 to 1/4 pi cos square theta d theta. If it was cos theta, would be easy. But cos square theta, we need to do something, which is we know this identity. Cos 2a equal to 2 cos square a minus 1. If I take this minus 1 to the left side, we get cos 2a plus 1 equal to 2 cos square a. Divided by 2. 2 and 2 cancel. So cos square a is cos 2a plus 1 over 2. That's what we will substitute here. Then we got rid of the square. So 0 to 1/4 of pi cos, since 2 is under both, so let's write it outside. Cos 2 theta plus 1 d theta. This 2 I wrote outside so that does not interfere with our integration. So now we can integrate it. 1 over 2 cos 2 theta, its integration will be sine 2 theta and divided by the differentiation of the angle, which is 2 with respect to theta, plus this is 1, its integration is theta. Then we write c from 0 to 1/4 pi. Let's substitute them now. 1 over 2 sine 2 times, in place of theta we'll write 1/4 pi over 2 plus 1/4 pi plus c minus, we'll write half again and we'll substitute 0. Sine 2 times 0 is 0 degrees over 2 plus 0 plus c. Sine 0 is 0 and 0 divided by 2 is 0, gone. This is already gone. This c cancels with this c, so this half has no role. So we are left with only this one. So what is that? Half. 2 and 4 cancel, so sine pi by 2 over 2 plus 1 over 4 pi. So what do we get here? Half. Sine pi by 2 is 1. So 1 over 2 plus 1 over 4 pi. If you want to make them same denominator, we can multiply here by 2 and here also by 2, so that they have same denominator. We can add them. So half, and we get 2 plus pi. Yeah, 2 plus 1 pi divided by 4. And the simplest form of this will be this 2 and this 4 can multiply. 1 over 8, 2 plus pi. This is the exact value of the definite integral we were given. Okay. Next question is about complex numbers. Okay. The complex number u is defined by this, where a is a positive integer. Okay, this will help us. Positive integer. Express u in terms of a. Okay, and this should be the format. X and y are real and exact. So what they mean to say is that just rationalize the denominator. That's what we're going to do. Square root 2 minus a square root 2i over 1 plus 2i. This is given. To rationalize the denominator, we multiply it by its conjugate. So 1 minus 2i is conjugate of this. So we can't multiply only 1. We have to multiply numerator as well. And now we can multiply them one by one. Square root 2 times 1. Square root 2. Square root 2 times minus 2. So that's what it will be. Minus a, okay, minus a square root 2 only I. And then it multiplies, it will be positive a 2a square root 2i square. divide by. If you see, it is a plus b, a minus b format. I keep on using this in my videos. This is an identity, which is a plus b, a minus b, which will be equal to a square minus b square, and that will help us to rationalize the denominators, which it becomes 1 square minus 2i square. So do we have something adding here? Oh, this I square has to be -1. So we will have to rewrite this. The square root 2 minus 2 square root 2 I minus 2 a. No, let's write a square root 2 I, and then plus, not plus. Now it will become minus. Why minus? Because this I square is -1. So -1 multiplies with this becomes 2 square root 2a. And 1 square is 1. And this will give us 2 square is 4, 2i square, right? Which will be 2 square I square. 2 square is 4 and I square is -1. So because of there is negative already 1, so it will become positive and 4. Okay. Can we take something common here in this and this? Yes, we can. So square root 2 taken common from this and this, it becomes what? 1 minus 2a. I can be taken common, square root 2 also can be taken common from this. So minus square root 2 and I, and we'll be left with a plus 2. Okay. So let's complete it here. Divide by 5. So what do we get? Let's just separate them. Square root 2, 1 minus 2a over 5 minus square root 2 a plus 2i over 5, right? And that's it. This can be written. So they said x plus iy format. So this is x and this is y. So you can write here x equal to square root 2 1 minus 2a over 5. Y is, they said plus iy, right? And we have a negative here. So it will be negative square root 2a plus 2 over 5. And that's it. No I, because I is part of the format. This is how we get answer. Next, please. Question number, this is 7a, so we may have a 7b as well, which we have it here. It says now it is given that a is 3. Very good. Write u in terms of this kind of r has to be positive and theta has to be between minus pi and pi, giving exact values of r and theta. Let me rewrite what we got earlier. Then we will substitute a equal to 3. We got square root 2 1 minus 2a over 5 minus square root 2 a plus 2i over 5. Now they're saying a is equal to 3. So we'll substitute this a equal to 3. Square root 2 1 minus 2 times 3 is 6 over 5 minus square root 2 3 plus 2 over 5 I. 3 plus 2 is 5. This is 5. They're multiplying. So cancel out. 1 minus 6 is negative 5. That means this 5 and this will cancel, but there will be a negative here. So what are we left with? Let's see. Minus square root 2. Nothing else. Minus square root 2i. Okay. This is the simplest form. But we have to put in this format. That means first we have to find modulus r. R is the square of the real part, which is minus square root 2 plus square of imaginary part. So that comes out complete 2 plus 2. 2 plus 2, yeah, because it's square root and not actually square root, because this negative becomes positive and then this, they cancel out. So 2 plus 2 is 4 and square root of 4 is plus and minus 2, sorry, plus and minus 2, but we'll write just plus because they said r is positive. Where is it? R is greater than 0. That means we will not write negative. So r we got as 2. Now we have to find theta also. For theta, let's visualize this on, this is real, this is imaginary on Argand diagram. So real part is negative square root 2, negative square root 2 somewhere here. And the imaginary is also negative square root 2. That means this is the complex number, negative square root 2 minus negative square root 2i. And if we join this with the origin, our angle will be, the argument will be this one. Okay, so let's complete this triangle and find this particular angle. Let's call it not theta. Theta is the one which is the argument. So let's call it alpha. Let's call it alpha. If you find alpha, we can find theta. So this length is square root 2, this is square root 2, we can find tan alpha equal to square root 2 over square root 2. I am ignoring negatives, though I could have put, but I am not putting because I want this angle which is an acute angle. Yeah. So alpha equal to tan inverse 1, which is pi by 4, 1 over 4 pi. Now, if we go this way, this angle is negative pi. Yeah, they said theta is between negative pi and pi. So, what will be theta then? Theta will be negative pi, and in this direction, it's positive. So, plus, we just got it, 1 over 4 pi. So, the answer is negative 3 over 4 pi. This is theta. They wanted this format, r e to the power I theta. So, u becomes r 2 e to the power I, rather negative because of 3/4. This is the format they wanted. So let's see if what is next, if it is C part or, yeah, it is C part. So using your answer in part B, we just got, find the two square roots of u. Okay, so what was it? Let me write. U was equal to 2 e to the power negative I 3 over 4 pi. Yeah, give your answer in this. Okay, the same answer should be there, and square root. That means square root means give then power half. They have also given r is greater than theta. It is different r. Okay, it is not the r in part B. There will be new r and there will be new theta. Okay, and square root this one also. Okay, so we get square root. Let's call that something else. Let's call it w. So square root of u is w. That's what I'm saying. So what do we get? Square root 2, this one, and e to the power minus 3 over 8 pi. Right? This could be the only answer. Right? But if you remember, our drawing was like this. We got this one, right? And we got this as w. How about this? If I would have gone this way and crossed theta, not theta, pi. We crossed pi and you got more than pi, but when I square rooted, square root will be smaller because it is more than 1. Pi is 3.14, correct? So it will be much more than that. If I square root, our new answer, I told you this theta in this part C is different from the previous one. Square root will come within our range. So second answer, let's call it W1. Second answer will be square root 2 remains square root 2. The length will remain same for the modulus, but it will be e to the power minus, not minus, I'm taking the positive side now. This is positive, right? So I, and this is positive, pi plus pi by 4, right? This is the whole angle, which is, this was pi, positive pi, and this we got in previous part as 1 over 4 pi. I'm adding, that is the 1.5 of this, right? So let's see what we get as second. Square root 2 e to the power I, and this is 5 pi over 4, right? And this 2 will multiply with denominator here. So we get square root 2 e to the power positive I 5 pi over 8. This is the second answer. This is W2. This is W1. So what do you learn in this one? That if something is squared or halved or 1/4, if we have to cross the limit and then you go back to your limits once you square root it, you should go for it. Okay. Next question. Okay, number 8. The equation of a curve is this. Express dy over dx in terms of x and y. So we can clearly see that they are combination of x and y. So we have to use implicit differentiation in this. How it is done, I will explain while doing it. Because we will differentiate with respect to x. So whenever there is x, differentiate it normally. Yeah, that's how x cube will be differentiated as. Whenever there is y, again differentiate it normally first, but put an suffix dy over dx. Okay, because you differentiated with respect to x. So we have to add this after 3y square. Similarly here, 2xy, they're multiplying. So we'll use product rule in this case. So let's write 2x and differentiate y, which is 1. But since we differentiated y, we have to write dy over dx. Then we will write 2y and differentiate x. No need to write any dy dx because we differentiated just x. And differentiation of 8 is 0, which is equal to 0. Keep the dy dx on left side only. 3y square dy over dx plus 2x dy over dx. Bring others here. Minus 3x square minus 2y. Take dy over dx common. 3y square plus 2x is equal to, let's take minus common from these two, 3x square plus 2y. So dy over dx is going to be minus 3x square plus 2y divided by 3y square plus 2x. Express dy over dx in terms of x and y, and we have done that. Okay, there must be a b part also. This is the b part. The tangent to the curve at point x equal to 0 and intersect at the acute angle alpha. Find the exact value of tan alpha. Let's try to visualize this one first. So suppose this is x-axis, this is y-axis, curve is somewhere. I'm not interested in curve. They're saying when x is 0, in this whole y-axis, x is 0. Let's say it's here, right? The tangent at that point where y, okay, we have to draw a tangent on this. Suppose tangent is this. I'm not saying this is the right tangent, but just trying to visualize. So this is the point of the curve, and where we drew a tangent, it came like this. Okay. And when y is 0, suppose y is 0 here and the tangent is this. Okay. The acute angle alpha. Okay. Find the exact value of alpha. So this is alpha. The two tangents where they are meeting, they're forming an acute angle alpha, and they are asking what is tan alpha. Okay. So can you see here? The tangent, first of all, you should know that dy over dx is actually the gradient of tangent, right? And whatever angle it makes with x-axis is the value of tan that angle. If this tangent is making this angle, let's call it theta 1. Tan theta 1 will be equal to dy over dx and this. This is the second angle they are making. Let's call it theta 2. So tan theta 2 will be equal to the gradient of this line, right? So in this triangle, can I say that theta 2 is alpha plus theta 1? Can I say that? Because this is exterior angle of the triangle. It is always the sum of two interior angles of a triangle. So alpha plus theta 1 is equal to theta 2. So, or I can write theta alpha is theta 2 minus theta 1. I'm not sure which one is theta 2, which one is theta 1, but whichever is bigger, seems to be bigger, I will take that as theta 2. All right. So this should be known to you. Right now we will use this one. So they're saying the tangent, the point where x is equal to 0, the tangent we have to find first. So we just got dy over dx equal to, what was that, minus 3x square plus 2y over 3y square plus 2x. So when x is 0, when x is 0, we'll write minus dy over dx. Let's call it m, the this thing, tan theta 1, let's call it tan theta 1 for the time being. So let me undo this. Yeah, tan, because dy over dx is tan theta, that's what I said here. So tan theta 1 will be equal to minus 3 times 0 square plus 2, and we don't know y. That means when x is 0, we have to find y also. So leave it here incomplete and we'll find y. Y when x is equal to 0, and for that we need to know the equation of the curve, which was x cube plus y cube 2xy plus 8. Okay. X cube plus y cube plus 2xy plus 8 equal to 0. This is 0, this is 0. Y cube equal to negative 8 and cube root both sides. Y is minus 2. Go back to this, 2 minus 2 over 3 minus 2 square plus 2 times 0. So we are getting tan theta here, which is minus, this is 0, this is 0, ignore, minus 4 over, this is positive 4 times 3, 12. So it comes out to be 1 over 3. That is theta 1. Let's call tan theta 2. And in tan theta 2, y is equal to 0. Right? Let's find x by using the same x cube plus y cube plus 2xy plus 8 equal to 0. So x cube equal to negative 8 and x is also minus 2 when y is 0. Alright, so we'll use the same minus 3 x is what? Minus 2 plus 2y, y is 0 this time, 3 0 square plus 2 times minus 2. So what do we get? 4 times 3 is 12 minus 12 over this 0 minus 4 positive 3. Okay, so which one is bigger? Theta 2 minus theta. Yes, theta 2 is bigger because it is 3 and this is 1/3. That's fine. Okay, so now we will use, they're asking us to find tan alpha, right? So because alpha is theta 2 minus theta 1, that means tan alpha equal to tan theta 2 minus theta 1. And the identity for tan A minus B is tan A minus tan B divided by 1 plus tan A tan B. We know everything. So tan alpha equal to tan theta 2, we just got tan theta 2 as 3, minus tan theta 1, 1 over 3, 1 plus 3 times 1 over, they cancel out, 3 minus 1 over 3, 9, minus 1, 8 over 3, over 1 plus 1, 2. So this is a denominator, this is also a denominator, they can multiply, so we can get 8 over 6. And if we cancel this, divide by 2 both sides, we get tan alpha equal to 4 over 3, and that is our answer. Okay, question number 9 now. In the diagram, this is a cuboid, OA is 2 units. Let's try to understand that. OA, O to A, that means here up to here, this unit, this vector is 2i. Okay, it is I direction and 2 units makes it 2i. Okay, OC is 4 units, so OC up to here it is 4j because this direction is j. OG is 2 units here, that means it is 2k. Okay, now what are they asking us? They have given M is the midpoint of DF, that means this side and this, they are equal, and AN is 3 times NB. AN is 3 times NB. If this is 1, this is 3 times that. 3 plus 1, 4 units, because this is 4j, that means up to N it is 3j, up to B from A is 4j. Okay, that's how we interpret all this. Express the vectors OM and MN in terms of I, J and K. Let's talk about OM first. OM means tail is at O, start at O, reach at M somehow. So this is O, I want to reach here M. So I will go to A first. So it will become OA, first vector, plus then AD, and then DM, and we reached M. Okay, let's see how many of them are in terms of I, J and K. OA, we know OA is 2i. AD is parallel to OG, that means it is also 2k. AD is 2k. DM, in this direction we don't have any IJK, so for DM I'll do some work here. Can I say that DM is half of DF? Yeah, because they have said this is midpoint, so DF, its half is DM in same direction. So if I find DF somehow, I will get DM. So DF can be found. So starting from D ending at F, I go this direction first, which is minus 2i, isn't it? So minus 2i, and then I go along GF, which is parallel to OC, which is 4j. Got it. DM is in terms of I and J now, so plus half minus 2i plus 4j. And let's open the brackets and simplify. 2i plus 2k plus half of minus 2i will be minus I. Half of 4j will be 2j. And if we rearrange, OM comes out to be 2i minus I is just I. Then we have 2j and 2k. This is the position vector OM of M. That means the coordinates of M can be written as 1, 2, 2. Position vector gives us coordinates of that head M. Alright, second one was MN. So let's try to find MN. Starting at M, ending at N. So I go back to D, so MD first. Then I go down to A, DA. And then A to N. MD is opposite of DM. We just found DM, so we'll just put minus here, so that comes out to minus half minus 2i plus 4j. DA is opposite to 2k, right? It is going down, not up, so minus 2k. And this a to n is 3j, we have already discussed 3j. And now open it, minus half positive I, and then half of 4 negative will be minus 2j minus 2k plus 3j, which gives us a I minus 2j plus 3j is just j, and then we have minus 2k. This is vector mn in terms of I, j and k. Earlier we found om. Okay, second part of this, find a vector equation of line through mn. So basically this line they're asking, starting from somewhere, reaching m, then going to n, and then going down. This line, we have to find the vector equation of this. For vector equation, what do we need? We need a point on the vector. We know this point 1, 2, 2. Let's convert it to vector, which is position vector I plus 2j plus 2k. That's point. Then we can start, we can take a parameter. I'm taking m, and then we have to write the direction of the vector mn, and mn is known to us, I plus j minus 2k. This is the vector equation of this line. A point, any point on the line in terms of vectors, then a parameter, and the vector, actual vector of that line, which is mn. We got this. This is the equation of this particular line. Okay, what next? Show that the length of the perpendicular from O to the line through mn is square root 53 over 6. From O to this line, this length, they're saying prove that this length is square root 53 over 6. So let me redraw it somewhere else, and can I? Yes, I will get the points. Let me redraw it here. So this is m somewhere, m, the coordinates are 1, 2, 2, and this is somewhere here n, this is O, and this is perpendicular. Okay, let's call this point as K. Okay, now because these two lines, this line and this line are perpendicular, it means that their dot product is going to be 0. Whenever two lines are perpendicular to each other, their dot product is 0. The vectors dot product, that's what I mean. We know the vector here, mn, this is a vector, so we can write, let me write in column notation, it is easier for that. This is 1, 1 minus 2, 1, 1 minus 2, dot this vector. We know this is 0, 0, 0, but we don't know k, right? Let's say that this is the equation for k also, because k is on the line for which this is the equation. So the coordinates for this k will become what? 1 plus 1m, 1 plus m, comma 2 plus m, comma, and then it will be 2 minus 2m. These are the coordinates of this point k, right? Because it is lying on the line. But we are interested in this vector. Because this is 0, 0, 0, the position vector will become the vector we need. So which will be 1 plus m, 2 plus m, and 2 minus 2m. This has to be equal to 0. The dot product has to be equal to 0. So now we'll just, in dot product, we multiply the x component with the x component. So 1 times 1 plus m is 1 plus m. 1 times 2 plus m is 2 plus m. Minus 2 times this will be minus 4 plus 4m. This is equal to 0. So m plus 4m, 6m equal to 1 plus 2 is 3. 3 minus 4 is negative 1. But if I put it on the right side, it becomes 1. So m is 1 over 6. So the coordinates are known to us now. Coordinates of k are 1 plus m, 1 plus 1 over 6, 2 plus 1 over 6, and 2 minus 2 over 6, which comes out to be what? 7 over 6, 13 over 6, and 12 minus 2, 10 over 6. Okay. Now we are, if these are the coordinates of k, right, what we got just now, OK is what we need, and we need its magnitude, because they're saying the perpendicular distance from O to k, and that is the magnitude of OK, and OK is nothing but this 7, 6, this is the vector OK, right? Its magnitude 7 over 6 square plus 13 over 6 square plus 10 over 6 square is equal to how much? 49 over 36, 169 over 36, and 100 over 36. If I calculate, it comes out with 318 out of 36. We can cancel this by 6. And yes, OK, which is perpendicular length, is equal to square root 53 over 6, and that is what they wanted us to show. Okay, question number 10 and the last of the exam. The curve y equal to x square root sin x has one stationary point. They're confirming it in the interval from 0 to pi. We can see in the graph also, this is the stationary point where x is equal to a. Show that tan a is equal to minus half a. So we know that for a stationary point, dy over dx has to be equal to 0. And let's find dy over dx of this they have given. So y is x square root sin x. So this has a variable, this has a variable x. So that means they're multiplying. We'll use product rule, which is differentiate x but don't differentiate sin x. Then don't differentiate sin x but differentiate, sorry, don't differentiate x but differentiate sin x. So differentiation of x is 1, don't need to write, just write square root sin x, plus x will remain x and sin x. Let me do sin x. Can I write like this? Because it is square rooted, half. For differentiating this, half will come in front. So half. And the exponent will go down by 1. Sin x half minus x. Further, we have to multiply it by the differentiation of what is inside the bracket, which is sin x. So its differentiation is cos x. Okay, so let me write here. Dy over dx is equal to square root sin x equal to, I can write it x cos x over 2, not equal to, plus x cos x over 2, and half minus 1 gives us negative square root sin x. So we'll make it a denominator. To make it positive, half as the exponent. This is the differentiation. Now this has to be equal to 0 for finding the x coordinate of this. So let's do what? Let's take the sin x to the other side. So x cos x over 2 square root sin x equal to minus square root sin x. Let's multiply this here. So x cos x equal to minus square root 2. This 2 will be complete here, and square root sin x times square root sin x is complete sin x. Okay, now let's get rid of this cos x so that this becomes tan x. Yeah. So let's complete it here. X equal to minus 2 tan x. Is it matching with what? Tan a minus, so that means this minus 2 has to go to the other side. So we get minus 1 over 2x equal to, this cancels, tan x. So when x is equal to a, it becomes tan a equal to minus half a. That's what they wanted us to show. Yeah. Let's go to the next one, where they say the verify by calculation that a lies between 2 and 2.5. The solution of this equation lies between 2 and 2.5. Whenever we have such a situation, always do what? Put all of them to one side. So tan a minus the plus now half a equal to 0. Right? That means if we both of them are on one side, they should be equal to 0 to get the value of a. But 2 and 2.5 are not the values of a. So that means if we substitute 2 and 2.5, we will not get it equal to 0. So let's see when a is 2. So what will we get? Tan 2, and obviously we have to use radians, not degrees. Half 2, is it equal to 0? No, it will not be. So tan 2 plus 1. Just put this in a calculator. Let me do it myself. By the time I do this, I would request you to subscribe to my channel, like this video, share with your friends, and motivate me to make many more videos like this. I get minus 1.185. And when a is 2.5, what do we get? Tan 2.5 plus half of 2.5. We can't cancel this, so let's put whole thing. In my case, I'm getting 0.50297. So can you see it was negative, it became positive. That means between 2 and 2.5 values of a, somewhere between we have 0. So that means the value of a lies between these two. Okay, so we can write change in sign of the expression value indicates the presence of root between a equal to 2 and a equal to 2.5. This is how we show it. What next? Show that if a sequence of values in interval 0 to pi given by the iterative formula this converges, then it converges a to a, the root of the equation part a. In such situation, what they mean is that this particular iterative formula can result into the equation, original equation they have given in part a. So whenever we want to do that, convert this to the equation of part a somehow. So in that case, what do we do? N plus 1 and n we ignore and just write x, both of them as x. X equal to pi minus tan inverse half x. No n plus 1. And we should get back what is needed. So can I write like this? X, rather let me put this tan inverse to the left side. So I'll write tan inverse half x equal to pi minus x, right? So half x becomes tan pi minus x. Alright, so what does it mean? That means, let's look at this. They said x is between 0 and pi. So if this is x, suppose this is x, right? So pi minus x, this is pi minus x, isn't it? Pi minus x. Don't you think this angle will be an obtuse angle? Obviously, if it is in first quadrant, that means it is less than 90. This is a obtuse angle, and tan of an obtuse angle is negative tan x. Or else, if it is in this quadrant, yeah, because they have said between 0 and pi, so it can be here also, and this is x, right? So what is tan pi minus x? Will be, this is pi minus x again, and the situation is same, right? It is actually in second quadrant, that's why it is negative. So in both cases we can write half x is equal to minus tan x, right? And this is exactly what is there up in part A. If you look at there, tan x equal to minus half x. So we can write this as, which indicates tan x is equal to minus half x. That means part A converges according to this iterative formula. Okay, next. Use this iterative formula given part C to determine A. Okay, so let me first write that one here. Tan xn, let me write here, xn plus 1 equal to pi minus tan inverse half xn. So since we know the answer of this is between 2 and 2.5, let's start with the number which is exactly between 2 and 2.5, 2.25, or x1 we can write. So let me write x2 here. So that means x1 is 2.25 equal to pi minus tan inverse half 2.25. Just use your calculator and you will get your answer. So x2 comes out to be, in my case, 2.2974. Similarly, we'll find x3 now. x3 is pi minus tan inverse half times 2.2974. Yeah, 4 digits they are saying we have to write every time. So if I do that, x3 comes out to be 2.2871. So in this same sequence, x4 will be pi minus tan inverse half times 2.2871. So x4 I get 2.2893, and we should stop here. Why? Because if I round off this one to 2 decimal places as they are asking here, 2.29 I get. This is 2.29. Two consecutive parts are rounding up the same number. The first one was 2.30. So since we got same in two consecutive iterations, so our answer is x equal to 2.29. If you want to confirm with x5, you can try, but I'm sure it will be staying the same. So let's finish this video now, because this was the last part. If you like the video, please share with your friends and subscribe to this channel. Thank you very much.